Hello, and welcome to this tutorial. In this tutorial, we're going to be taking a look at retargeting facial motion capture data with Reface. Now, in the Mocap tab, in the toolbar window of the 3D viewport, you'll see the Reface tab. If you open that up, you'll get a message in the sub-panel that says that there are no armatures in the scene. That means that you have to actually add an armature to the scene before it will even display any of these elements. And once you do that, you can select it as your facial rig. Of course, it needs to have a facial rig associated with it in order to actually retarget any motion capture data to it. But as long as there is an armature in the scene, at least one, you'll be able to see these properties in the interface. We can go ahead and look at a few of these properties right now. The first is that you can restrict the visibility of the selected facial rig in the viewport, and this is simply for visualization purposes. If you're trying to navigate around the viewport, and if you're trying to navigate around in the viewport and locate your facial markers and then locate a bone, it's nice to be able to simply hide the armature with the quick of a button without having to hide and unhide everything. We can go ahead and open up another scene that I've actually already started working on. And there we go. So I have this guy again, and he has a facial rig associated with him. He is actually rigged, and this facial rig is parented to this body rig. I have the face rig selected as the facial rig that we are going to be constraining, and that is this rig right here. Now, just to give you an idea of what's going on in this scene, this first layer is the character mesh. This second layer is the armature layer. I've got my facial rig and my body rig on this layer. I don't actually need these visible, so I'm going to go ahead and hide these. Let's see, on the, I think this I always get these confused. This is these layers down here, whether this is 9 or 10, I don't know. But on this layer, I have some imported C3D format motion capture data. Now, I've just downloaded this off the internet from some online resources that are kind of making this freely available. And this motion capture data, as you can see, it's fairly decent. It actually moves around in the scene. This has been tracked with some other facial motion capture software that will actually capture all of this global movement. So this was not done with Blender. This was done in some other program. Now on the I'm going to call this the 10th layer, just for the sake of this tutorial. On the 10th layer, I have a lot of facial motion capture markers here, and this was actually recorded and captured with Blender's tracking tools, and this is my own performance here. So this has no global motion in it. This has no head motion, and we're going to be taking a look at the difference in just a little bit, because this is part of the retargeting process, and I have some tools to make it easier to get rid of this global head motion in this set of markers. So let me go back to the first layer, open up our armature layer, and let's go ahead and take a look at some of these properties in the Reface panel. This list right here is for creating pairs of markers with their respective bones. Now, these bones are obviously going to be part of this face rig. So let's go ahead and select a marker, and I'm going to be using these markers for the time being. I'm going to select all of them. And what I can do is click this button. It will create a list of every marker that I've selected, and you can see that the marker is assigned. It's looking for a bone. Currently, there is not a bone assigned to any of these marker bone pairs, and that's what I'm calling them. I can't think of another word for them, so that'll have to do. The marker exists, the bone does not yet. So I have not assigned any bones to these. So this will do nothing yet. The next step is going to be assigning bones to each one of these markers. Now you can do this one by one. For instance, um, I've got, let's see, brow. I'm calling that brow inner. And this brow.c is this marker right here, and I don't actually need this one because I don't have a corresponding bone in the facial rig, and I also don't have bones for these forehead markers, so I'm going to go ahead and get rid of those. I also don't have bones corresponding to these chin markers or these cheek markers, so I can go ahead and get rid of those as well. And those are not actually orbicularis bones. That should be called something else. So this is about all that I need right here. I'm going to go ahead and remove these from this list because I'm not going to do this manually. You could do this manually. I could select my corresponding bones. Let's see, brow inner .l, and I could do that one at a time. And every time that I add a bone, it's going to give me a message in the interface here that says that 43 pairs of marker bone pairs are still missing bones. So it's not going to do me any good if I try to retarget anything right now. So you can do this one at a time. I'm going to go ahead and click remove all markers to remove these. Now, just to demonstrate this process, you can do this one at a time. If you select one marker, it will not have a bone associated with it. You just go ahead and do that yourself. Or you can select multiple markers. It will add one pair without a bone for each marker that you've selected. Remove all those again. The other way that you can do this manually is by selecting, for instance, I've got the brow inner marker selected here. I could go ahead and go into this facial rig, select the brow inner marker, create a new pair, and it's going to oh, what did I do? I've got something wrong selected. Let's try that again. I've got my brow inner marker selected, got this one selected. I had another bone selected, that's what happened. And so it's assigned the marker and the bone that I have selected. So I could do this manually, going ahead, selecting each one of these. And when I do that, I'm also going to probably want to hide the marker. So I can click Auto Hide Marker in this menu. So it's selected now. Let's try this again, and it will add those, and it will also hide the marker so that I can just continue to go ahead and select another one. Oops, only want that one selected. It'll add that one, and it'll have hidden that marker as well. So as I continue to do that manually, it'll hide all the markers until I get to the last one. And that's a good way of kind of visualizing the ones that you've already added to the list without having to go back and read the list and make sure that you haven't selected that one already. So I'm going to go ahead and undo these, unhide these markers. And the last way of doing this is actually not manual but automatic. You can select, I'm going to leave this off, auto select matching bone. Now that I have that selected, in this menu you get two new fields, one that says replace and another that says with. And what this is going to do, it's when you click, when you select your marker and you add it, it's going to search this facial rig for a bone with a similar name. So for instance, I have marker labeled brow underscore inner.l, and there is a corresponding bone in my facial rig that says brow underscore inner.l, but it also has a prefix of capital TRK hyphen. So what I'm going to do is replace, actually no text, because there is no prefix or suffix or anything on my facial marker itself. I want to replace that. With capital TRK hyphen when searching for a matching bone. So the reason for that is obviously that this TRK is the only thing making that name any different. So when I click, when I select a marker and click add one, then it's going to automatically find that tracking bone with the TRK prefix, and it's going to add it to the list. So I'm going to go ahead and do that for each of these. I don't know that I have all of these labeled completely correctly, but we'll go ahead and find out. Now there are still some more that are missing. I've got different naming conventions for these here. So cheek inner L, Let's go ahead and just do this manually, and I'm going to go ahead and do this and then pause the video so that I'm not wasting everyone's time. Once you have your markers selected and added to the marker bones list, and you don't have any more pairs that are missing bones, that message will disappear, and you can begin to modify them. Now, the first thing, it says constraints to animation. This is actually for when you've created your motion capture data using Blender's tracking tools, and if you click the button that says set as background, and then the button that says link empty to track, these will each have a follow track constraint on them that will be following the active clip. So when you click this button that says constraint to F-curve, what that's going to do is take the camera solve or the object motion solve that you've done, and it's going to apply the constraint so that it no longer follows the camera and is no longer dependent on the camera, but it will actually have animation data associated with it. You can see that down here in the timeline, I already have keyframes on every single key. So I've already converted these constraints to F-curves. But if you haven't done that yet, and these are all kind of dependent on the camera still, because that's how you've solved your, that's how you've captured your information, then you're going to want to click Constraints to Animation after you have created this list, because it's going to take every marker in this list and apply the constraints and create animation data from that. Now you can see that the tooltip says, be advised, this takes time. This can take a while. I mean, it can take upwards of, 30 seconds to a minute, depending on how much animation data you actually have. So it does take a while, but that's just kind of par for the course. It is kind of time consuming. You can also edit the marker size in the viewport, which is kind of nice when you're selecting markers and you need to kind of navigate around them and you don't want to have to deal with this mess. Then you can shrink them down so that you can visualize this easier. The display, you can set it to plain axes, arrows, sphere, cones, any of the other empty display types. And I find that sphere just kind of generally looks a lot nicer than having little arrows sticking out all over the place. So I'm going to leave that on sphere. Now this renaming, these renaming fields and this rename selected button, this is actually for when you are organizing your markers in the scene. This will actually rename the selected markers that you have. So for instance, if I select, let's say these three these three cheek markers here, and I wanted to give them something like a prefix of cheek underscore mid and I don't know .r. I don't know, just for the purposes of this demonstration. And now I can add an index, and it will rename them, cheek mid 2, cheek mid 1. And I don't want to do that because I've got them named correctly now. But this is how that'll work. So, for instance, if you've made all these tracking markers and you need to rename them so that they're coherent and you can actually work with them without having to guess which ones you're working with, then you can use this renaming function. Okay, let's go ahead and look at retargeting. First thing to be aware of is that the scale of this animation data is very different from the scale of the bones in the facial rig. Now, if I was to try to constrain these directly, these bones would be constrained to these markers and they'd be jumping around all over the scene. Obviously, these bones can't be moving this far. The face is going to be completely deformed, and it's not going to work correctly. So what we have to do is scale the animation on these markers down to match the scale of the facial rig. So that's what this checkbox is for. Auto scale animation will actually take the animation, will find an average distance between the bones in the facial rig, the average distance between these markers, and it will calculate the difference, and it'll scale the animation data to match that difference. If you do that, you can enable Save Original to Disk, in which case it will save the original animation of these markers to your hard drive so that you can reload it later on if you need to recover it for any reason. Now, this is actually dependent on the name of the blend file that you're working with. So if you change your blend file name or if you import these into another blend file, then this is no longer accessible to you. You need to this is dependent on the name of the blend file in order to recover this marker animation. There are two modes to work with. One is use constraints, and the other one is copy animation. We're going to look at use constraints for now. Actually, that's what we're going to do. We're going to use to retarget this motion capture data. Auto constrain bones. This will automatically constrain the facial bones to their respective markers. And again, this is using all this information from this list. So this is all dependent on creating this list first and it being complete. Delete rotation data. Sometimes if you have rotation data on the markers for if you've created your motion capture data in Blender's tracking tools and it has some rotation data, that may be unnecessary to you, or you may actually want to keep that depending on how you're going to be setting up drivers and things like that. So you can automatically delete the rotation data using this. We're going to take a quick look at using copy animation because there are caveats. Once you actually enable copy animation, you'll see some extra parameters pop up right underneath this marker bones list. We're not going to use copy animation to retarget right now, but it's worth taking a look at. What we are going to do is, well, let's see, we can enable arrows to show the axes of these markers. So these are actually rotated. This isn't a big deal. The animation is all the same. This is using global animation coordinates here. So it's not a problem if I reset the rotation here. It's still going to work correctly. But I'm going to go ahead and leave it like it was. And you can see, actually, I am going to go ahead and disable the rotations because those all have 90-degree rotations on them. And the reason I want to do that is so that I can visualize where these are moving. So I've got obviously my x-axis going in the global x-axis, the z-axis going in the global z-axis, and the y-axis matching the global y-axis. On my facial rig, on the other hand, if I show axes, you can see that, orthographic view, you can see that I've got my z-axis matching the global z-axis, but my x-axis is actually inverted. It's not matching the global x-axis. The same applies to the y-axis. Now this is important because if I were to try to copy the animation directly, let's go ahead and open up another window here. If I were to go ahead and copy the animation from, say, this brow inner marker, if I copied the animation data from its z-axis to the bone z-axis, that would actually work. If I copied its y-axis information to this y-axis, that would be inverted. And the same goes for the x-axis. Now, in some cases, you might have set up your rig differently, and your z-axis may be pointing some other direction, and your y-axis may be pointing upward, and your x-axis may, maybe pointing along the global x-axis, and you're going to have to compensate for that. So, depending on how you've set up your rig, and actually how you've set up each individual bone, there are controls that will allow you to copy one axis to another. So if I'm going to be copying the z-axis information to the z-axis information on this bone, I can copy the z-axis information to the z-axis information. I want to copy the y-axis information to the negative y-axis, and I want to copy the x-axis to the negative negative x-axis on the bone. So if I set it up like this for this brow inner marker and the brow inner bone, then this will copy this. This will copy this correctly. Now I would need to do this on every single bone because every single tracking bone here has the exact same orientation, and so does my collection of markers here. What I can do instead is use an axis global override. I would copy the negative, or the x to the negative x, y to the negative y, and the z to the z. Now, if I was to go ahead and retarget the facial motion capture, it would copy all the animation data correctly. I'm not going to do that right now because I am going to use constraints and making sure that I'm on frame 1. And the reason for that is that the rest pose of my facial motion capture is on frame 1. I think I may have a few more frames, but the very first frame is the most neutral rest pose of my facial motion capture data. So I want to use that as the reference point for copying this, or rather for scaling the animation down to copy it to the rig. So this is a very important kind of caveat to retargeting. You need to do it on a very neutral rest pose. So we can go ahead and looks like we've got everything set. We can retarget this facial motion capture. It tells us that it successfully wrote the animation data to disk, so that if we need to recover it later, we can. I'm going to set these back to sphere display and maybe bring this down in the viewport a little bit more. Let's see how that works. Yeah, it's working okay. It's not fantastic. I can actually stand to maybe scale the z-axis information here on the eyelids and maybe even on the eyebrows. Maybe get rid of the x-axis movement on the outer brows here, since it's not necessary. And let's see. Other than that, it looks pretty decent so far. Maybe with a little bit of cleanup, it can look better. But that's a start. The next thing that we can do is to start cleaning this up. And if you open up the graph editor, we'll see that there are some tools. Let's see. Select all the markers. And we can see that there are some tools here. There's a panel called Reface F-Curve Tools in the Properties toolbar of the graph editor. And we can choose to scale F-curves. We can smooth the F-curves, which uses a slightly more controllable smoothing operation than Blender's native, native smooth keys operator, because it'll actually give you a window of keyframes to average for the smoothing process. We can visualize only the X location F-curves, the Y location F-curves, or the Z location F-curves, so that anytime you need to see something, you don't have to go and click Z, 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 and then hide everything but those. You can hide them all and visualize them all at one time. So selecting these, maybe these, there we go. If I select these eyelid markers, and I want to see the Z location F-curves, I want to scale them down a little bit, maybe by 75%. And again, when you do this, you want to do this on a frame that is a neutral rest pose. You don't want to be scaling the markers animation data from a point where they're fully transformed, because it's going to actually use the location of this cursor as the point for scaling. So if I were to scale them right now, say by 50%, then it would scale them around the current frame. But what I want to do is scale that animation data around the rest frame. So let's see what this looks like. It may be a little bit too drastic. Maybe not. No, maybe not. But maybe go just 75% instead. Oops. Okay. And I'm also going to want to maybe delete, not that one, the x-axis information. going to want to delete the X location F curves on these selected markers. You can see that it's gone ahead and done that. So these no longer have any X-axis information, so they're not going to be moving around all over the side of the head, because that's not really necessary. And the same goes with these guys right here. This isn't really necessary to, well, at least for these, it's not really necessary. The same is true of these eyelids. I don't need any of the eyelids to have X location, there we go, F curves. I stand to bring those down a little bit more. But again, this is a start. So with a little bit of cleanup, it's looking okay. I could compensate for some of the deformations by adding some more shape keys and some more drivers, and making it look a little bit more automated, a little bit more realistic. But this is definitely I'm off to a good start here. So the next thing we're going to do in this tutorial before we call it a day is to look at facial motion capture stabilization. So opening up this window again, let's get rid of this timeline. I'm going to, let's look at this imported C3D data. I'm not going to select all of these. I've got some of these grouped. I've got the head markers grouped together, and I have the facial markers grouped together for easy selecting. So I'm going to add these facial markers to this list. Obviously, there's not going to be any bones associated with these, because I'm not actually going to retarget these to the facial rig. So let's open the facial stabilization properties, and you can see that there is yet another list. And what we're going to want to do is add the head markers to this list. Now these head markers need to be stable. What that means is that they cannot be deformed by facial muscles. They need to be on a part of the head or on the temple that is not going to be causing them to move around when the facial muscles move. So they need to be static. They need to move with the head, but not with the muscles. When we add a marker to this head markers list, we want to set its position. So for instance, these are on the right side of the head. Now this is from the actor's perspective. This is the right side of the actor's head, the left side, and the center. So I need to set the position for these. Now I've got some on the left side as well. So those are on the left. And I've got two ones in the center, head L.C and head R.C. So these are center markers. What we can do next is select whether to keep the original markers. Now what that's going to do, if you disable this, obviously the other options disappear. If we want to keep our original markers in the scene and not modify them in place, then we can keep the originals. We can hide the originals if we'd like, just to get them out of the way once we've completed the stabilization process. And we can automatically update the marker bone list to be populated with the new stabilized markers. Now if we keep the original markers, we're going to want to add a new prefix to give them a new name, because this is actually going to create new markers in the scene. So for instance, the default is stbl_, just a prefix for stable. And let's look at what happens if we stabilize these. Yet again, we need to be on frame 1, since that is our rest pose, our very neutral expression. And it's going to take the information from your start frame in your scene to the end frame. It will not go beyond that when stabilizing. Now you can see that these markers actually go well beyond the end frame here, but just for the purposes of this tutorial, I'm actually only going to go ahead and go to 250. They go to 750. They have 750 frames of animation data, but this will actually take a while. If I create new markers for 750 frames of animation for every single frame, for every single marker, then this is going to take a while. So I'm just going to do this really quickly and only only stabilized 250 frames of the animation. So let's go ahead and see what this looks like. Okay, now it looks like a big mess, but this has actually populated our list with the new markers. So really quickly I can just edit the size of these in the viewport, and you can see that it's actually centered these markers in the scene. So if I start playback, you can see that these aren't moving around with the head, with the global head movement anymore. Now they are a little bit jittery, and just the mocap data itself is actually not terribly accurate. You can see that some of these markers kind of jump. That was in the original animation, right there. Yeah, some are moving around right there. It's kind of erratic behavior, but that was actually in the original animation. That's not that's not the fault of Reface. But the jitteriness is from removing this information from the global information. Just the process of adding these new keyframes make this a little bit jittery. So what we're gonna do with these new markers is we can go back to the graph editor, open our F-curve tools panel. Let's open this window a little bit farther. Select all these markers, open this window, and we can we can smooth these F-curves. Now we can choose to smooth the X, the Y, and the Z individually. We can disable the X or the Y, or whichever we want to do, or we can simply smooth all of the F-curves. So for this case, since these are all pretty jittery, I'm going to smooth all of the F-curves. Now this is going to go through each keyframe and average out the information. So you don't actually need to be on frame 1 for this process. You can. I just like to do it as a matter of habit, but you don't. It's not absolutely necessary. So let's smooth the F-curves. See what happens. That's a little bit better. Some of these could stand a little bit more smoothing. See what that looks like. Yeah, they're still a little bit jittery. But we can try this again with the size of 3, the smoothing process. Those are better. It's looking all right. Again, you can change this window size. Size 15 is actually pretty drastic. I think that's gonna be a pretty severe smoothing on these F curves. And the more you smooth, the more sharpness you lose. So you're getting the jitter out, but you're also losing some of the sharpness of the movements. For instance, if you have the eyelids coming down really fast or blinking, or the jaw opening and closing really fast, then you're going to lose some of the sharpness of that animation by having a really large window. So I generally just keep it at the low default of 3, and that works pretty well. So that's a look at facial motion capture stabilization and retargeting with Reface. And the process is meant to be pretty painless. You can see that this works. This has worked pretty well. This is some pretty quick motion capture that I got just from using Blender's motion tracking tools and using link empty to track, and then copying the constraints to animation, and really simple naming conventions. Keeping everything sort of standardized with my markers and my bones helps to populate this list really quickly, and the process can be pretty streamlined. Thank you for watching.